Hello everyone. This tutorial is specifically for the Bio 105 Lab Exercise 1. We're going to give you an idea of how to graph in the computer program Excel and how to perform a statistical test called a T-test. Now, what you're going to want to do is you're going to want to make sure that you have Excel. So we've set up a link in Blackboard where you can get it for free through the University of New England. There are other ways to do this sort of stuff, but we're going to be using Excel so that everybody's on the same page. And so when we talk about it, we're all using the same techniques to do what we need to do. So first, let's talk about what a student's t-test is. So if you have reviewed the lecture about the scientific method, I talked in there about how we need to be statistically rigorous when we're talking about our data. We need to make sure that what our data looks like it's saying is what is actually going on. So the student's t-test is one of those ways of doing that. It was originally developed by William Seeley Gossett. Now, he worked at the Guinness Brewery. His employers didn't want him giving away secrets, so he had to publish it under an assumed name, and the name he used was student. So it is called the student's t-test, not the Seeley-Gossett t-test. So it's a method of hypothesis testing. So it determines if there's a statistical difference between two data sets. So you're going to see this term null hypothesis a lot. The idea with the null hypothesis is that the null hypothesis is that there's no difference between these two data sets. All right, the means may show slightly different numbers, but there's no actual difference between the data that generated them. If we do the t-test and it tells us that there is a difference between these two groups, then we can reject the null hypothesis, and that means there is a difference between them. What you generate with the t-test is something called a probability value. All right, so in science, we're generally looking for a p-value of under 0.05, meaning we're at least 95% confident that there's a difference between the means. So this is just a brief overview of p-value and the t-test and what those terms mean. I will add a link in Blackboard if you want to get into more detail about the actual math that's involved in calculating these. But for now, what we're going to do is we are going to show you how to graph your individual data and how to use Excel to generate the t-test. So I have generated some data here. All right. If you have watched some of my videos, I do tend to use and okay quite a bit. So let's imagine that we went back through all of our videos, and for each exercise we counted up how many times I used each of those. Right? So we generated these two sets of data, one for and one for okay. So one of the first things we can do to take a look at these is to generate a mean. Right, basically an average of the number of times I used both of those. So what we're going to do is we're going to say mean number of ums and mean number of okays. All right. Notice that we have our data. It's nice. We try to keep it organized. It's always got to be labeled. If it doesn't have a label, all right, it's just a number. It's not data anymore. So let's generate those means. How would we do that? Well, Excel is relatively easy to do. All right. Anytime you want to do a formula, all you have to do is hit the equal sign. And that tells Excel that everything after this is now going to be a formula you want it to perform. In this case, there's a couple ways to do the mean or an average. You can either go to this little text box up here and pull down average. All right. If you do it there, the nice thing it does is that it will try to predict what you're doing. All right, and say it's guessing that, okay, I've got a column of numbers here. So do you want to have me do an average of B3 through B15? And no, we don't, right? Because we put this in there, that's not an actual number, so we want it to only go to B14. The other thing you can do is you can click on this, and you can go in and select your data set, which you have to delete the old one first. All right. There we go. All right. So once you hit OK, it has generated an average for those. And if anytime you click on it, it's telling you that it's doing an average of B3, right, through B14. For this one, there's a couple different ways that we can put the formula in there. The easiest is if we click on the little corner here and we just drag over, and it will fill in the formula for that column. So if we click on this one, we can see that now it is doing column C, right, the same way instead of column B. The other thing you can do is you can always go in and type in the one you want. All right, and it'll start giving you suggestions. And then we just have to close it in with parentheses. So you would select what your, oops, sorry, wrong column. You'd select your data, close off the parentheses, enter. All right, those all are ways of doing the same thing. So now we've generated our two means. What we'd like to do is go ahead and take a look at them side by side. So now you can look at the numbers and say, okay, the average number of OKs is quite a bit bigger than an average number of ums, but we want to visualize that. So what we want to do is go down here, and you'll see in a second why I put those labels on there. Because what that's going to allow us to do is now we can go up and we want to insert a chart. All right. So we're going to go to this first one up here, which is all of our bar charts. All right, we're going to do a 2D column. And because I put those titles there, the mean number of ums and the mean number of OKs is our horizontal axis labels. So this isn't complete. Now what we need is we need to be labeling our data. So one of the things we can do is that we can go up here and we can, where it says add chart element, and what we're going to look for is, remember, you've got the X and Y axes, so we can look at axes titles. We want a primary vertical one here. All right, so we need to label what these numbers are. If there's no label, they're just numbers, right? So if we come in here and we change this, all right, to mean number of times using a word. Okay, so now when we look at this, we know what those numbers are. All right, and then for our other axis, click back on here, we can go back up and we can add our primary horizontal ones, and here we would call this word used. Okay. And one more thing we're going to do with this is we are going to get rid of the chart title. Because generally in science, what you're going to have is a figure caption below your graph. And that's something we'll talk about as we're going on. So now we got one last thing to do, and that is to generate our t-test. Okay, so we have our block there with an equal sign in it. We can go here to more functions, all right, and we can type in something like Ttest. So there is our t-test. All right, we're going to hit OK, and now it is going to ask us to fill in some information. So array 1, we've got two columns of information. So array 1 is going to be the first column. There we go. Okay, so I'm clicking and dragging to highlight that. Array 2 is going to be our second column, so I'm clicking and dragging to highlight that. Our number of tails, all right, so we haven't gotten into a whole lot of detail on this, but we're going to just tell it that our number of tails is 2. It's basically meaning that's looking at both sides of our mean. And then our type is also going to be 2. So that generates, all right, our p-value for our t-test. So because that value is less than 0.05, we can say with confidence that yes, there is a difference between these two means. We can reject the null hypothesis that says that there is no difference between these two sets of data. So we're confident that there is a difference between these two means. All right, so now it's up to you guys to go through and do the same thing to your cricket data. Thank you for watching, and we will see you in lab.